Okay? All right, so to use SOHCAHTOA, must be looking at a right triangle. Okay? And if you're going to draw a right triangle for me, I'm not going to know it's a right triangle unless you put the right angle in the corner. So put your little tick mark in the corner. Okay? When you use your trig ratios, you want to pick one of the acute angles, and you're going from that acute angle. So we're going to name this acute angle. A lot of times it's called the Greek letter theta. Okay? In a right triangle, the side opposite the right angle has a name, gang. What is it? That's the hypotenuse. Okay? Now, if you put your finger on theta, the other two sides from theta, the one across from my finger, you always put your finger on the angle, guys, it always works. The one across from my finger is called the opposite. The one next to my finger is called adjacent. Now, how do you distinguish between adjacent and hypotenuse? Aren't they both next to my finger? Okay, hypotenuse is always the longer side and it's across from the right angle. All right, everybody good? Okay, 3 trig ratios that you guys have already studied. Sine. Remember, we don't sin, we sine. Sine, always by the word goes the angle. If you know the measure, you put the measure by the angle. If you just know a letter, you just put a letter by the angle. If it's just theta, you just put theta by the angle. Okay? Next one is cosine of theta. And then tangent of theta. Okay? SOHCAHTOA. The O and the H stand for opposite over hypotenuse. So sine of theta would be opposite from my finger over hypotenuse to my finger. Cosine of theta. Haley, what do you think the A and the H stand for? Adjacent over hypotenuse. So I want to talk about adjacent to my finger. I have 2 that are adjacent, but one of them is always the hypotenuse. So adjacent over hypotenuse. And then tangent of theta. Max, what do you think tangent of theta stands for? Opposite over adjacent. Very good. Now, is this familiar to you guys? Coming back now? Tangent is opposite over adjacent. Good. Okay. Each of these trig ratios or functions has a reciprocal function. So reciprocal, also called the co-function.
Is that like the -1?
No, that's called the inverse. Okay? The reciprocal function of sine is labeled CSC. That stands for cosecant. Cosecant. Always by the word goes the angle. Okay? And Kayla, smart young lady that you are, how do we reciprocal opposite over hypotenuse?
Sine or opposite what?
So how do we reciprocal that?
Oh, hypotenuse over opposite.
Very good.
Does it say
Co-function. Co-function. So hypotenuse over opposite. Okay. Cofunction of cosine is SEC, secant. You need Kleenex? It's up there. Okay. All right, Joel, how do you reciprocal cosine? So what do you get after you reciprocal it? What do you get after you reciprocal it? You said adjacent over hypotenuse. There you go. Hypotenuse over adjacent. Okay? Good? The cofunction of tangent is cotangent. Theta. Okay? Sierra, how do you reciprocal tangent? What do you get? Very good. Adjacent over hypotenuse. Adjacent over opposite. Sorry, I meant to write opposite. Okay? All right, example 1. Let me give you a right triangle. Let me give you a theta. Let me give you a 5 and a 12. Okay? Can you first label your hypotenuse? So can you label each side from theta? So Nat, from my finger, what is 12 called? Opposite or adjacent?
Opposite.
And 5 is called?
Adjacent.
Yes. It's always from your finger. Trust me, if you put your finger on the angle, this will always work. Okay? All right, so let's set up our ratios. I always set them up, guys, so that they match. So I write sine theta, and then underneath sine theta, I write cosecant theta. And then I write cosine theta, and underneath, I always write secant theta. So it helps me remember how to match them up. And then tangent theta, cotangent theta. Always by the word goes the angle, always by the word goes the angle. Okay? All right, let me put my finger on the angle. Brianna, sine is what word over what word? Good. What side is opposite my finger? And hypotenuse to my finger? Oh, never mind. I'm sorry, we did not find the hypotenuse, did we now? Okay. I think we're going to need to use something from yesterday. So what did we derive yesterday? Yeah. So let's use Pythagorean theorem. A squared plus b squared equals c squared. I'm so sorry. I forgot to find the hypotenuse. Okay. What side has to be c, gang? The hypotenuse. So this side has to be c. So a and b, it doesn't matter which is which. So 5 squared plus 12 squared equals c squared. This is why I wanted you guys to have your calculators. So c squared equals, what did you get, gang? 169. And then square root. So Max says c is? 13. So sorry, now we can set up the rest of our ratios, can we not? Okay, so Brianna was telling me it was 12 over 13. And guys, the ratios have to be reduced. They have to be reduced. That is reduced. So that is done. Very easy, Brianna. The cosecant is then what? There you go. Delightful. Miss Hannah, from my finger, cosine is what word over what word? Good. What side is adjacent to my finger? And hypotenuse is? What'd you say?
I said 12.
Hypotenuse?
30.
There you go. And then the secant, Hannah, is the reciprocal, which would be? Yeah, and guys, don't change that to mix. Leave it 13/5. Okay? All right, Mason, tangent. What word over what word?
Opposite over adjacent.
Okay, set it up.
The 12/5.
12/5. And then Mason, cotangent is?
5/12.
Yep. All right. In trigonometry and in geometry is if the vertex angle is labeled big A, then the side opposite is little a. If the vertex is labeled big B, side opposite is little b. And then big C, little c. And what other word can I label that side C with, guys? That's the hypotenuse, right? Okay. To solve the right triangle, you are given little b is 15. And that is it. So now you guys have to find little c, you have to find little a, and you have to find angle B. Okay? Is there something easier to find first? Miss, the angle B? Okay. So measure angle B. What math are you going to do, Leah, to find it?
180 minus 90 minus 100.
That a girl. All right, can you guys punch that out and tell me what you get? Okay, now you can either write the answer over here. I prefer personally, I write the answer in the picture and then I circle it. Circling it means it wasn't given to me, it was something I had to find. Okay, now it'd be great if we could use Pythagorean theorem to find A and C, but you know what, we can't. Because Pythagorean theorem only works when we're trying to find one of the two. So I guess we're going to have to use our SOHCAHTOA to find either A or C. And it won't matter, guys, which one you find first. So I want you to take your finger and put it on the angle. Okay? Let's find A first of all. From the angle, I'm looking for the opposite to my finger. I know the adjacent to my finger. So, Miss Maya, what is opposite and adjacent? Which trig function?
Tangent.
Tangent. So we're going to write down tangent. Always by the word goes the angle. Always by the word goes the angle. Always by the word goes the angle. We're setting up trig ratios. So tan of 28 equals opposite A over adjacent 15. So now, master solvers that you are, box in A, we want to get rid of divided by 15. Drew, what's the inverse operation of dividing by 15? Multiply by 15. And this is where it's such a big deal that your calculator is in the right mode. All right, then what would be one way to find the missing C side? What do you guys want to do to find the missing C side, Brianna? Yeah, you could do Pythagorean theorem. Can you set us up, Brianna, in Pythagorean theorem then?
Oh, no, 8 squared plus 15 squared.
Equals C squared. Okay, sounds good. And I'll let you guys can punch that out. You don't need me to punch it out with you. 17. Circle it. Now this is actually called a Pythagorean triple. Our trig unit is full of Pythagorean triples. A Pythagorean triple is when each side comes out to be an integer. 8, 15, 17 is a Pythagorean triple. Do you need to know the triples? No. If you know them, will it make your life a little easier? Yes, it will. Okay, so just so you know. All right? All right, the other time you can do decimals is for application problems. Okay, so application problems, you guys know, are things like real life problems. So here's our real life problem. This will be fun. We have a building.